Good morning, everyone, and welcome to this month's CEBRA Research Webinar, or CEBRAnar, as we like to call them. My name is Jessica May, and I'm the Director of the Research and Innovation section within Biosecurity Strategy and Reform Division here at Department of Agriculture, Fisheries and Forestry. So just before I start, I would like to acknowledge the Ngunnawal people as the traditional custodians of the land many of us are meeting on today, and recognise any other people or families with connection to the lands of the ACT and region. I wish to acknowledge and respect their continuing culture and the contribution they make to the life of this city and region. I extend that recognition to the traditional custodians of all other lands on which our staff and participants are gathered today, and to all Aboriginal and Torres Strait Islander peoples attending today's webinar. So I know a lot of you aren't joining from Canberra, so you're on a different country today. If you'd like to acknowledge that country, please just pop it in the chat. So we have everyone, sorry. So before we begin, could we please make sure that everyone has their microphones on mute and everyone besides the presenters' cameras are off today. So today's session will be recorded and available for those unable to attend. There will be an opportunity to ask questions after the presentation, but please feel free to add questions as we go in the chat on the side. And you can also use the hand up at the end where I will throw to you to actually ask the question. For any of the newcomers today, the Centre of Excellence for Biosecurity Risk Analysis is a long-standing biosecurity research initiative hosted by the University of Melbourne. We have a new 4-year agreement now underway, and CEBRA will continue to provide the Australian and New Zealand government with expert biosecurity risk analysis and advice that helps inform a range of biosecurity risk management activities. So today we will hear from Dr. Matthew Cantele and Professor Tom Kompas as they delve into the new TEEMS package for computation general equilibrium, so CGE modelling in tariffs, trade and pest pathways. Matthew is a research fellow at CEBRA. He is a researcher and scientific software programmer focusing on CGE models and implications of socio-economic change for biosecurity risks. He has served as an author in multiple intergovernmental science policy platform and ecosystem services assessments and published on topics such as sustainable development goals, climate change, land use degradation, and scenario analysis. So Tom is a chief investigator at CEBRA. He is a professor of environmental economics and biosecurity in the School of Agriculture, Food and Ecosystem Sciences, and the group director of the Centre for Environmental and Economic Research, so CEA, at the University of Melbourne. Right. He is a recipient of the Eureka Prize in Science, the CSIRO Medal for Research Achievement, and is a distinguished fellow at the Australian Agricultural and Resource Economics Society. So I'm going to hand over to Tom, who's going to introduce today's talk, and looking forward to hearing everything that you've got to say.
Great. Thanks, Jessica. And I'm sorry for you having to go through all of that in my intro, but thank you anyway. Great. Thanks everyone for joining online. It's really appreciated. We're going to today launch a new software package, an R package for doing CGE models that Matthew has put together. An open source, transparent, easy to use package that can be available to anyone. In fact, it is really easy to use, as you'll see. CGE models are used throughout the economics profession by academics, by government, by Deloitte, EY, comparable organizations. They're very common, and in fact, traditionally were used to look at the impact of a tariff on national incomes and on the pattern of exports and imports across the world. Indeed, it can be done for up to 140 different countries, 70 different commodity groups, heavily weighted to agriculture, but also including manufacturing and energy and other sorts of sectors as well. They're very well known, very useful. Those who, in fact, indeed, they're conceptually easy to understand. They're computationally very difficult because of the dimension, but very easy to understand conceptually. Within each one of these up to 140 different countries, you have inputs, capital, labor, land, natural resources, and they're combined by firms to produce one or more of these 70 different outputs. And these outputs are either sold or consumed or invested domestically by firms, by consumers, by government, or they're traded overseas. So you get a pattern of exports and imports as a result. And then the practice is to shock that system and say, what happens if there's a tariff, say a Trump tariff, that has an impact on national incomes and trade flows? Very common. The problem with them is that, generally speaking, they tend to be non-transparent. Economists who don't do CGE models often refer to this system, this CGE system, as a black box. Not quite sure what's going in, even though it's well-established data out of the University of Peru, GTAP data, and you're not quite sure how it's coming out, or what, you can see what's coming out, but you're not quite sure how it's done. Computationally, it's unclear. And indeed, most of the profession uses proprietary software, GEMPAC, GAMS, to do this sort of work. So it makes it less, indeed, transparent, and certainly not open source, and often not easy to use. If you're online, if you've used GEMPAC or GAMS, you know it can be a bit of a challenge. Moreover, the traditional approach, 98, 99% of the profession, tends to use what are often called sort of, or what I think of as spurious expectational assumptions about the future. So for example, they'll assume that consumers estimate forecast prices in the next period based upon this period's value or a weighted average of past values. And that can work in some cases, but in many cases, it's totally inadequate. Yeah, for example, let's say government puts in a climate change target for emissions reduction in 2050. Well, you want to be able to look forward, to project forward as a consumer, as a firm, to try and plan in accordance with that target, rather than waiting with static expectations period after period after period until you get to 2050 and see what the effect is. So we've solved that problem as well. And indeed, work that Pham Ha and I have done in the past have now introduced what's called a rational expectations framework, some sort of limited set of uncertainty principles that go with the modeling, and also have solved it using an optimal profile so that people can look forward. What's nice about today is that Matthew's taken all of this material, all of this standard, more or less standard CGE material, built it up into something bigger, better, and more wonderful, a game changer, a true game changer, in a platform that's open source, so that you can reproduce the results, relatively easy to use, and it's totally transparent. It's an R package, and it's a relatively easy to run R package. Indeed, people run it at the moment who don't have much knowledge about CGE, but can still do a shock and say, well, if Trump tariffs change tomorrow, what's the effect on incomes and exports and imports? Now, for biosecurity, who can flip the slide, Matthew, for biosecurity, that's really quite important. If you've looked at one of our presentations for Project 21B or checked that report, we use this kind of model to ask the question, what happens if there's global warming pathways going forward as a result in particular of heat stress? And what we found doing that, using this CGE model, is that the damages from global warming are quite heterogeneous. They vary across the world. Huge impacts from heat stress in Africa, South Asia, China, Southeast Asia, some other places as well, less so in other parts of the globe because you're just looking at heat stress at the moment. And that results in quite large changes in the pattern of exports and imports. And that's what the lower left panel shows. It shows that, well, we'll import less from China, more from other parts of the world, including Europe and so on, as a result of these climate change impacts, all conditional for pests that are coming here across pathways where you have suitable climate and you have a habitat suitability that's appropriate for them to enter Australia. So you can sit there and imagine, okay, you can go look at 21B at some point, but you can imagine what's the impact. You can do an experiment. You can say, give me a simulation, give me a projection of changes in Trump tariffs, changes in trade agreements, global warming impacts on incomes, on the pattern of exports and imports, and potentially on pest pathways into Australia, and indeed on what happens to exports of agricultural commodities from Australia to the rest of the world. With global warming, these increase quite dramatically. Um, it looks like there may not be a picture on the screen, but we'll just keep going anyway and see if we can sort it out. Um, that's unfortunate, but that's okay. We'll be fine.
I think it's on my screen, Tom. I'd have
It's
to
on
take
mine.
over.
Yeah, it's on my screen. Can you see it
Oh,
now? Can the people online see it now?
probably not.
Probably not. Okay, they can see it. How
You
about
have to
now?
open up. If you
How,
open up the PDF on your computer and share your screen, I think that might be the only way to do
well, it
it.
looks like we're getting thumbs up, so I think we're okay.
Okay.
Let's leave
Yeah,
it.
everyone can see it. It's fine. So when you
Okay.
shared it,
Okay.
it was working.
Okay.
All right.
Okay, good stuff. So yeah, imagine you can do that. And you can do that experiment, that simulation, without waiting for some researchers like Ha or Matthew and I to do it for you. You can do it yourself. And in fact, with Trump tariffs changing day by day or week by week, you'd want to know fairly quickly what the impacts would be. With global warming, you want to know what the impacts will be. In effect, what this does, and it's the way I like to think about it, in a biosecurity context, it gives you a sort of import risk assessment going forward. You're asking the question, well, if we have changes in tariffs or changes in global warming, what are the changes in pest pathways? That's what's cool about it for DAF, I think, for those of us like me who work in biosecurity. But generally speaking, you can use these CGE models for a number of different case scenarios and a number of different shocks. So that's the overall pitch. The game changer, don't have to pay for Genpack, you don't have to pay for GAMS, you don't have to use those frameworks, which are all deterministic, have no uncertainty attached to them. Um, and instead, and they again may have spurious expectational assumptions. You can use this framework, and you can do it yourself. So with that, was that a good enough pitch, Matthew? I think it was a good
I
enough
think so.
pitch.
Yeah.
I think so. With that, I'm going to turn it over to Matthew to talk about the platform itself and give you a high-level introduction to it. I mean, today is the launch of the beta version of the program, which you can access, and indeed will help you use it if you like. But it's the launch today, and kudos for Matthew for putting this together. It's been an incredible effort, and I think, again, a really profound addition to the economics profession. Over to you, Matthew.
Thanks, Tom. Just before I begin, can you just confirm that this slide is visible?
Yes, all good.
Yes. Oh, good. Okay. I'm a bit paranoid about these things after recent experiences. So thanks again, Tom. And yes, today we would like to introduce you to the beta version of TEEMS. And so what is TEEMS? Well, it is the Trade and Environment Equilibrium Modeling System. The environmental components are forthcoming. But as it stands right now, it will handle nearly any quote unquote vanilla CGE model. We've put together a GitHub organization called TeamSphere, which is inspired by Tidyverse, where we've begun to collect all these repositories which are associated with running CGE models, and this is all public, so you can go to these repositories now and have a look. So I must say that, first of all, that again, this is a culmination over a decade of work. When I began the PhD some years ago at the university, Tom handed over the solver, and that's where I started and continued. So I'm presenting the collective efforts of many individuals here today. So what is TEEMS? Well, in a nutshell, yes, it is the very first open source software to handle all aspects of the CGE model. So from start to finish, it's all can be done within this R package. So today we're gonna go over just a quick introduction to CGE models because they're relatively unknown. It will be a high-level overview. We'll talk a little bit about why this was put together, what motivated us, a little bit about reproducibility, which is sorely lacking in this field. We will hit upon a high-level overview of TEEMS. Now, for those of you who are CGE modelers, we are happy to sit down and do a more detailed presentation of the package. It would take far more time than what we have today. And then we'll move on to how this package is relevant, both in terms of recent projects, Project P21B, and specifically for policymakers, and then also for other researchers. And I just want to emphasize here that this has been a package that's been put together for everybody. This has not been oriented towards CG modelers, and we've made very conscious decisions along the way to have this be accessible. And then finally, we'll talk about some future applications extensions. So, what are CG models? This is the usual figure that you get when we're trying to explain what a CG model is, and this is the core of the what is now the standard GTAP model, which is the most used model in CG modeling. And so what a CG model is essentially it's a system of equations that represent relationships between different parts of the economy. And there are value flows between all these aspects within the economy. And within the model itself, you have the option to either to specify variables, that is to give them exogenously, or to have the model adjust using the equations within the model to the exogenously imposed variables. And these impositions are known as shocks, and they simulate policy changes. So I really want to highlight here that this is not a statistical model, but it often finds itself among statistical models. Either a statistical model is used to derive a trajectory that is fed into the optimization model, or the outputs themselves are used within a statistical model. Or in the case of P21B, it was sandwiched between statistical models. And one thing I would like to also highlight today is, in the past, I think we would be hesitant to call this a simulation model. It's more of a policy change model. But what we've done with this package is allow you to easily implement multiple shocks. And I believe that we are getting close to a point where we can confidently start calling this a simulation model, at least in the sense that you're able to control multiple aspects of the economy and have the model adjust. Okay, so what's in the box? This is a photo of me beginning my PhD with Tom. This is the Golden Jabbar box from Dune, and CG models are often referred to as a black box, as Tom indicated. They're not a black box, but they're not necessarily a box you want to stick your hand in, and that's been amply illustrated to me throughout the years, and that's something that we wanted to address. And so this work here is inspired and began during the PhD when I was working with the task to simulate long-term socioeconomic pathways, which turns out to be a rather large ask from a CG model. And during that time, I ran into numerous obstacles, and one of the primary obstacles was looking back at established literature which purportedly did simulate socioeconomic pathways and not being able to reproduce that work or even really know how that work was carried out at the computational level. So what this package allows us to do is to bring a little bit of transparency to CG modeling, so that you don't necessarily need to trust a CG modeler when they hand you the output of the CG model now, because they can hand you the actual script which generates the model and runs the model, and you can run it yourself. I think this is an important contribution to CG modeling, and it helps add a little bit more science into the economic science, let's put it that way. Another thing this package can do is, well, let's just say there are many ways the CG model can fail. I joke with the 101 ways the CG model can fail, but there are probably about that many ways a CG model can fail. And I've written into the package numerous aborts that are custom made to the error in question that help steer you in the proper direction when an error is encountered. But perhaps even more importantly here is CG models can also appear to succeed. The runs can appear to go through, but actually they haven't succeeded either, for example, because accuracy at a particular time step was lackluster, and that was used to generate base data at the next time step, or an error simply was not caught in terms of the input files that go into the model, because there are so many parameters that go into the model and so much data. And that's probably the far more pernicious of the failures that happen in CGE modeling. And finally, why? Well, it shouldn't be this difficult to run a CGE model, and that it really shouldn't. And it serves as, the difficulties stands as an obstacle into really advancing this discipline and using CGE models where they are very important in terms of biosecurity risk or understanding climate change damages and impacts. These are all topics that are incredibly pertinent, and we need to have more eyes and more hands, more capable people using these models. So real quick, what are we talking about with reproducibility here? Well, can a third party take and run your analysis? So we're talking about data, code, documentation. Now, in terms of CG modeling, we need to relax the assumptions here a little bit, or the requirements here, because currently we're really all dealing with proprietary software, and for the most part, everybody's using proprietary data, and for the most part, everybody's using proprietary software. To run the model, you need the actual model file, that's the Tableau file. You need all the inputs, this includes the base data, the sets, the parameter values. You need a closure and a shock, and you need to know how the solution was carried out. Now, I did a review during the PhD, and even if you put aside proprietary software and data, it is nearly impossible to find a CG model analysis that uses a CG model where all these inputs and all these requirements for it to be reproducible are presented. And even if you do, putting it together can still be very difficult. So again, CG models, not exactly a black box, but it's understandable why they have that reputation, and the work we're presenting today seeks to really to leave some of these issues behind. Okay, so like I said previously, if to really look at this package, we would need to sit down and have a workshop, and I could go through it. There are many very cool features that have been tailor-made for CG modelers, but here I'm going to keep it just a higher level overview of what the package is, and perhaps an explanation for why it's taken so long to put out. So currently we have over 122 named functions and over 100 aborts. So there are 100 unique aborts written into this package to handle an issue that would normally result in an error or not result in an error before the model is solved. It's built on the top of some really wonderful packages, data table and per. It is very fast. So putting together a medium-sized model in terms of writing the input files out, a couple of seconds. Solving the model itself, again, a couple of seconds in many cases. So of course, larger models will take longer, but it is quite fast. At its core, the solver employs low-level programming. So these are the HSL Fortran-based libraries, as well as PET-C. And all this low-level code has been encapsulated within a Docker container, which has been pre-built and is sitting on Docker Hub. So the process here is you will still need to acquire these HSL libraries. Academics can do that for free, and you can finish the build at your home or at your workplace. It takes a couple of minutes to finish the build, and then you have a solver ready to go on your computer. So Docker is a requirement here at the moment, and for those of you who are unable to use Docker, there will be a Singularity version coming as well. So one thing that I've been very careful to do here is to make this easy to use right out of the box. So there's a number of models and mappings that come shipped with the actual package. So you don't need to go and get anything. You don't need to go grab a GTAP model and modify it for compatibility. It comes with the classic and the standard GTAP models, as well as this the previous intertemporal model that Tom and Ha and Pham had worked on, and their fresh GTAP rational expectations model is also shipped with this package. So you'll have the option of running intertemporal models immediately once you install this. There's also a number of set mappings. So again, if you don't want to sit down and specify your regional sets or what sectors you want to map, and you just want to start running models, you can do that right out of the box. For regions, we have a range of sizes. For sectors, we have a range of sectoral focuses. It's currently compatible with all the available GTAP databases, and GTAP has always been good about making their database that's two databases out of release publicly available. So you can go and sign up with GTAP or register with them and acquire the GTAP database 9 right away without costing you anything. And finally, for the CGE modelers amongst you who have a v6.2 data format based model and you're a bit bewildered by the move to v7.0 standard data, that's all handled automatically within the model itself. So what you see on the right, this is a CGE model. This is all it takes to run it right here. This is an intertemporal model run through 2030 that imposes 10% tariffs on exports from China to the US. And that's it, less than 30 lines of code. So as you can see, it has been boiled down to just the bare essentials here. All right, so some implications. So this is where it gets exciting. Well, first we'll talk about what this means for policymakers. As we're all aware, the assumption of free trade is no longer supported by what we see in the world today, and indeed we see rather capricious application of tariffs. So that is really, in order to understand the impact of these developments, the CGE model is basically the quintessential model. That's what this model was originally built for. So it's incredibly pertinent to have this available right now. So traditionally, what would happen is, let's say a large free trade agreement is being considered. There's a long run up to the meetings. There's time to commission a study. Teams are called together, and many months later, a study comes out, and countries are able to understand if this is good for them or not, or in what way is this going to affect their national economies. That's in the era of tariffs increasing and decreasing on a weekly basis. That traditional approach is not really adequate anymore. And that begs the question: Are policymakers today, when they make decisions whether to acquiesce or to retaliate for tariffs, are they making informed decisions? And if so, how are they being informed? So what this software will allow policymakers to do is to, the day of receiving news that a tariff is potentially going to be imposed, to actually begin looking at the impacts of that tariff. And so we hope that this helps policymakers around the world make better decisions, and to not necessarily give in when they hold the cards, because sometimes they do hold the cards, but you wouldn't know that you hold the cards unless you were able to actually look at it in terms of, for example, through a CGE model. Okay, so what does this mean for projects like CEBRA, like the project P21B? So P21B was an enormous project. Like I said, we had a CGE model run that was sandwiched between two statistical models. In addition to the normal inputs to the CGE model, there were climate change temperature paths, there were a range of damage functions, everything needed to be mapped in terms of the time in order to accurately represent damages as temperatures were increasing. And we looked at this in terms of the impacts on land use, impacts on heat stress, for example, on labor, crop yields, and sea level rise in terms of loss of arable land along coastlines. So this figure you see on the right is just intended to demonstrate the complexity that went into just part. This is just part of what P21B was. Dr. Kamak's work takes up after this process with the pathways modeling. And one barrier to the previous workflow was that it could not all be encapsulated in scripts. So we like to work with, or many of us like to work with a package called Targets, which allows you to develop a pipeline of dependencies so that when you run an analysis, you don't need to worry about what runs first because it's all baked into the code. Now, with a script-based CGE model, this model itself can be just part of a analysis that's all carried out in our language. So this is a major improvement for those of us who are working with the code. I won't go into details here about specific shock types, but I've developed a shock type called a scenario shock, which if you have a full specification of a trajectory that you would like to simulate, it automatically generates aggregation-specific shocks depending on the aggregation that you choose. So what that means, for example, is if you have, let's say, a GDP trajectory for every region within the model, and you want to change your mapping so that you run a model that looks at East Asia and the Pacific, then those shocks do not need to be recalculated by you because they will happen automatically within that model. So this frees us where data is available from being locked into a specific aggregation. And you'll find if you look around to some CGE models, the model itself is aggregation specific. So the model always has these sectors. So this kind of gets us out of this lock and gives us more flexibility. As noted previously, the analysis can be reproduced, vetted, modified by anyone. And in terms of modification, this is nice because let's say you receive a script which shows what happened in P21B, and you want to add an additional shock. Let's say you have a tariff, or let's say you want to look at a damage at a specific sector. All you would need to do is write in another 5-6 lines of code, and that shock will be added to the analysis. Another area where, and I won't elaborate on this either, is we usually try to run as large a model as possible because there's usually a single model run which represents an analysis. And this is nice because it has all the connections in the economy that we want to see. And indeed, we always try to run as large as possible, but there are implications for accuracy. And one of the challenges to modeling climate change is that the damages are so large in some cases. So one thing that this will allow us to do, because it is script-based, you can begin to systematically run tens, hundreds, thousands of model runs, just as you would any other script. And for example, you would be able to choose a range of regional focuses, a range of sectoral focuses, or a range of parameter values that you want to represent. And you could write all that into a script and have each one run systematically. That's not possible with a graphic user interface in current approaches. In the case of P21B, this would allow us to begin simulating population, not just within the pathways model, but also within the CGE model. And the reason why that was left out initially is because you wouldn't be able to run a 70 by 40 by 40 model with the climate change damages that we had, plus population change. So again, this is giving us more flexibility to begin simulating a potential future rather than just looking at the policy implications of select shocks. And finally, for other researchers, and this has been something that I've thought about quite a bit, is how do we get more scientists using CGE models? So just as a preamble, we're looking at least 2 degrees of warming. I know there may be some that don't agree with this. I think Professor Hansen will be vindicated in the future, but it will be too late, and there will be no joy in that vindication. We are looking at potentially enormous damages around the world due to climate change. One issue that we have with CG models is that even though they encompass an entire system, we don't always have a large number of specialists working in every one of these modules within a model, simply because it's such a niche area of modeling that in the past what's happened is a economist or a CG modeler has become a specialist in a specific area, whether it's land use, in order to better implement those aspects of the model. What we want to see is the opposite of this. We want to see scientists who are already experts in these other areas to begin using CG models and improving the way that their their focus is being represented within these economic models. So, for example, there are ample areas when it comes to fisheries and forestry. Forestry is often left to partial equilibrium models. And when it's put into a CG model, it's usually not very elaborate. Fisheries as well is I won't go into how it's represented, but it is not sufficient. Land use has seen a lot of attention, but it could improve both in terms of how irrigation and soil is represented within the model. And finally, climate change damages. This is, there are so many aspects, so many vectors of damages that come from climate change that we really need larger teams and more specialists to represent what's happening in these models. And the unfortunate status quo is if you do not have that representation, if you don't have that specialist, then that damage is not captured. And we may be inadvertently providing policymakers with a more rose-tinted depiction of the future than that's actually in the pipeline. So finally, we need modelers and we need specialists to begin working with CGE models here. So finally, just some concluding thoughts and what is to come. One of the barriers to how CGE models had been running was that they were being run through a graphic user interface and through proprietary software. R is a full-fledged programming language. It's an incredibly powerful general purpose language. And I know that Python users can probably make a case for it being more general purpose, but there are actually a range of libraries within R which I found are more powerful than their equivalents within Python. We can quibble about this later if you like. Data table, targets, those are a couple. That we have all that power at our fingertips now when running a CGE model. So we're talking about models that have hundreds of coefficients, hundreds of variables. And in order to understand what these do, you have to dig through a model file that spans over 1,000 lines. Well, now these can be simply brought in as data objects, and you can query them within your RStudio browser. So this is going to make learning about CG models much easier. One thing that I want to do, and I aspire to do, is to write code to convert Tableau, which is the way that CG models are written for Genpack, into LaTeX and vice versa. This should be doable. All the basic these basic functions are in both languages, and this would be one step towards allowing scientists to begin using CG models. If you are a input-output table modeler, or if you work with multi-region input-output tables, there's already code that's being queued up to convert both the inputs in terms of the GTAP database, but also the outputs into input-output tables. So there's a number of different downstream modeling exercises that this will allow. So again, imagine running a shock, having a new trajectory represent a new potential future, and now you have an input-output table at that potential future. So this is you could refer to this as a potentially dynamic input-output table modeling. From the PhD work, I have a wide range of trajectories, both in terms of representing SSPs, as well as representing the last 10 years of economic history that will be eventually open sourced, so that you're able to begin modeling not just future trajectories, but also seeing how well do these models handle reproducing the past, because that they should be able to reproduce the past to a certain level of sufficiency before we begin reproducing the future. On the right, before I began working with CG models, I enjoyed data visualization, and Circos is a way of visualizing large data. The example here is not very large, but it comes from the epigenetics or genetic literature and visualizing a large data. And so these outputs from the model, I intend to write scripts to generate inputs that you can plug into existing web pages to have really cool visualizations that show you what exactly is happening in your model, and to actually give you a visualization of that, so you have a better idea of when this economic system adjusts to a shock, what exactly is adjusting. As I previously mentioned, systematically running thousands of model variants that will be the proof of concept that I use to present this model to academic journals. I won't give out way too much here, but we have something that is that will be really exciting to show. Now, not everybody is ecstatic about using R or script-based, but the good news is that there's the potential that this could either be used within the existing Biosecurity Commons framework, and there are many individuals there who are better designing graphic user interfaces than I am, or simply within a shiny interface, so that you don't have to use the code in order to run a CG model. And finally, we could potentially be looking at the beginning of the first open source integrated assessment model. Nearly all integrated assessment models have a CG model at their core, and these have never been available to the general public, and they've been scrutinized for the lack of transparency. And I think we're going to be able to make inroads here as well, and begin extending these CG models into integrated assessment models that can be run, again, by anybody. Thank you very much for your time today. If you're interested in testing, it is all up and available right now at this address. If you have issues, you can contact me. The solver has been vetted on Linux and Mac operating systems. We believe it works on Windows machines, but we haven't quite put the amount of time into testing Windows machine yet. But also, if you're not a CG modeler and you want to, you have an idea, and this is all a bit intimidating, we're happy to help. Happy to get you started. Like I said, the barrier to beginning with CG models has been dropped. It does not take that much time for us to mock up an example, given an idea of what you would like to do. Thank you all for attending. Thanks, Tom and Ha, for your work and your support along the way, and thank you, Andrew, as well for spearheading all this.
Great, thanks, Matthew. Can I just add one slide just for a minute?
Sure.
Let me share something. People have seen me, have probably seen this slide before, but if you stop sharing, I can maybe get it to work. Okay. I want to illustrate the power of what Matthew is doing. Um, this comes from a publication that Pham Van Ha and I put together in Earth's Future about 5 years ago, showing the impact of global warming in terms of heat stress, in terms only of losses in agricultural and labor productivity. And you can see at 3 degree plus warming, you get huge impacts just with limited damage functions, up to 28% fall in GDP. The average is 7%. The dollar amounts from now until 2100 are $610 trillion. So it's a no-brainer to try and cut emissions in terms of the cost of carbon taxes or emissions reduction. But my point for today is, well, first of all, you can see that the damages are heterogeneous, mostly near the equator, Southeast Asia, and so on. Greenland's picking up island countries. It's not per se experiencing damages. But here's my point. Ha and I did this using C code and a solver that we've developed. Now, it's reproducible if you know how to use C code. Good luck. It's a bit hard to do, and it took a while for these things to run. The benefit of Matthew's program is he can do something exactly like this. You can do something exactly like this without much headache. It'll run fairly quickly. It'll be seamless. It'll be open source. It'll be transparent. You don't have to rely on people like Ha and I with the elaborate C code. You can do it in an R package. And that's what makes it, I think that's a game changer. It allows you to run CGE models in a way that couldn't be run before. Those who use Genpack know it can be trouble. GAMs can be trouble. They're deterministic in any case. This allows you to do something much better, especially if you use the RE version of Matthew's platform. So that's where we're at. We're looking at sort of transforming how CGE is done generally. And thanks to Matthew for putting this together. It's quite amazing. I'll step out of this, stop sharing, and turn it back to Jessica.
Wonderful. Thank you so much. That was really, really interesting, and so great that we're kind of making big changes to giving us all access to these types of things in the future. I think that's going to be a really big difference. Is there any questions, if anyone wants to throw anything in the chat or anyone wants to put their hand up? I can probably start with one that I sort of had come through. So you were talking a lot about how you've simplified it, you've put it into R, it's much easier for us to access. So flipping that on its head, what do you think are the kind of biggest remaining barriers for us all to be kind of using these sorts of models in our day-to-day work? So
good question. So even though you can begin using the model, that doesn't make the model any less daunting itself. The models are rather large and involve many equations, many variables, some of which are not necessarily the variables that you need to be chalking or selecting to use. And so in that respect, you will still need to ideally speak with a CG modeler or try to get some advice on how to proceed, or at least look into the literature on the model itself. I think one of the barriers here is also one of my pet peeves, is that I think the models are too big. I think they're over elaborate. I don't think you need such large models to do what most of us want to do, and in some cases less is more. So I think, the general size of and complexity of the CG model, the concept of swaps is not one that is always not, understanding that if you replace one endogenous variable with another variable, what are the implications within the model? That there are still barriers that can be overcome.
Yeah. So Matthew, good points, Matthew. I mean, Matthew has a user guide that goes with the beta release, which will improve over time. So you can get started. If you try and learn Genpack, you actually have to take a course to do so. I mean, it's offered by Victoria University. It's a good course, I'm told, but you actually have to do a whole course. I think for Matthew's platform, it's not required to do a course. You may need a tip or two. You may need to do some background reading. But the R package runs pretty easily. Of course, I'm a CGE programmer, so I guess I can say that. The other sort of barrier is that it needs a Docker to run. Needs Docker to run. Initially developed in Linux, so if you're going to run it on Windows or Mac, you need Docker. Now that can be a barrier for some people, but it depends.
The manual will grow over time. So the manual is available, but it's also a beta manual at the moment. So I haven't I haven't really elaborated on aspects for non-CG modelers, but it should be, there is enough to get you going, and there's a repository that has scripts in it that you can immediately begin running on your computer. So you're not going to get a failed model run immediately. The danger is actually that you get a model run, but you're not actually able to interpret it correctly. But just to illustrate, the GIMPAC solver, which is what this solver was based on, the manual for that solver is hundreds of pages. So it's
400 pages.
So there's a lot here, and that can still be a barrier.
Hey, fantastic. So I'll just throw to the first question. So I think, Andrew, you had a question first.
Thanks, Jess. Matthew, that's a great presentation. I'm really excited by this piece of work that you presented. It's outstanding. Thank you so much. I'm being a statistician. I'm intrigued as soon as anyone mentions uncertainty. So this is a two-part, right? The first part is propagating uncertainty through nonlinear systems. What we know from Jensen's inequality is that expected values change when uncertainty is propagated through uncertain systems. So what you could do is you could propagate a mean through a system, and then if you propagated the distribution that the mean represented through the system, the mean of the end distribution would be different. And so you could test this, right, by changing the amount of uncertainty that's passed through your system, and that would actually give you some insight as to the potential error that arises from drawing conclusions about uncertain systems as though they were known exactly, which is a pretty significant weakness of complex modeling analysis. Second thing, and so first part question, have you contemplated a little experiment like that?
I would love to do an experiment like that, yes, but we will need to collaborate with individuals like you and Anka to do that. Yes, that's been part of my my uncertainty, or the analysis we did, and was often done with CG models, is you take the parameter most associated with the variable that you're interested in, and you vary it 10% up, 10% down, 20% up, and that is what is regarded to as yes, it is woefully inadequate, particularly because there's another 10 parameters within the model that aren't doing anything, and you're also not varying it. Are you varying it across all the elements associated with that parameter? So it gets tricky very quickly, and I think everybody has known for a while that it's more to get past reviewers than it is to actually examine how much uncertainty is in the analysis. So yes, we definitely want to do something like this.
I can see some Latin hypercube sampling in your future. Okay, so now the second part, so forgive me if I do a double-headed yes. Second part about this is that uncertainty is represented by variability. Now, variability also is relevant to discussions when we're thinking about not merely projecting the average behavior, but also the tails. And now I'm thinking about equity. Now I'm thinking about how do we capture the tails of a distribution of a population and what's going to happen to them as a consequence of political or policy decisions. Could we think about the CGE model representing uncertainty, but not as uncertainty about a thing, but actually as a population level variability using similar tools, and draw conclusions about the range of impacts across the range of stakeholders in an economic system, not just the average?
Yeah, I can get that one. I can get that one. I mean, that's again, Andrew, we have to work with you to do things like this. Indeed, the rational expectations approach I referred to is actually certainty equivalent. So there's a lot of work to do here. But the CGE model does generate the variability in a way that you're talking about, but on an average national level. But you can append to these models subnational versions that allow you to drill down a bit. I mean, Tasmania is different than NT, right? So the average for Australia, who cares if you live in NT? So that's the kind of work we want to do as well. A lot of subnational kind of attributions in this model, right?
Tom, thank you for that. I'm also thinking about variability within those areas. How do you capture variability within Tasmania? and the variability with it. And can you do that by propagating something that looks like uncertainty or plays like uncertainty?
Wow. Yeah. You'd need a data set to go with it for, not only subnational, but now sub-Tasmania data set, but why not? There are input-output models that could potentially be done like that.
Okay.
The representative household is a homogeneous unit, in the model. So that would be what you need to tackle.
Yeah, bad. Exactly right. And Han and I have been working on that for a bit, and we'll have Matthew incorporate it. Multiple heterogeneous households really quite important to get in.
But you make the model bigger, and it becomes harder to solve. So, and that really ties back into the models. I feel that we really need to shrink them first before we begin adding more to them.
Could be right.
Fantastic. Lee, do you have a question?
Hello. Hi, Tom and Matthew. Tom, nice to see you.
Yeah, good to see you, buddy.
On the screen. Thanks so much for the presentation. I think it's a huge step in terms for the CG modeler, also for CG, people like to practice with CG modeling, right? I'm hoping, so with your tool, I can still keep my job because I'm a CG modeler. So that means the question I would ask, so the CG model behind is still in its original source code, that's right? Like, Tom use G-type model, either C or GMPAG, they will be still in the original source code. So your package is kind of like a user interface. So you can make different shocks, change plummet, but the model city behind is still the same. Is my understanding correct?
The Tableau file that you would use is the same Tableau file that you would use with GIMPAC, for example. There are in some cases, there are some modifications for certain syntax which isn't compatible, but yet the Tableau file remains the same.
Okay, so it's basically, I mean, in the future, you possibly can expanding your model library. If, for example, if other CG modelers would like put their model into your model library, you can expanding. Therefore, you can run different, say, ensemble or something.
So most models that currently work with GIMPAC should work with this software. You will need to make certain changes. And what we will do is we've started with 4 models that are vetted. And if you take a look at those models, you can see where we've made small changes for compatibility purposes. Eventually, we are going to increase this library of internal models to include really as many models as we can. This is very easy to include in an R package. These are very lightweight text files. So that ideally in 5 years from now, there won't be 4, there might be 20 models to choose from. But in doing this, I also need to be careful about how different sources of external data, for example, if you're using a land use model and you need to load in, for example, the GTAP land use database, or if you have emissions data, there needs to be a systematic way of loading additional data into the model as well. So that we're able to extend to meet all these different specialist models. But if you have a model that you want to get working and you're having it's not working, contact us. I'm happy to take a look at it. Or you may be surprised. Like I said, there are a lot of custom aborts written in. It might tell you right away
what's wrong.
What's wrong. Yeah.
That's a real plus of the software.
And if it doesn't, also let me know so I can write one more in.
Yeah, I think sometimes it's so I mean it really depends on the complexity of the error. Some error probably really require some CG expertise to look into it. I mean, for example, you probably can put this in a appropriate closure, although you can try a lot of practice, but that closure basically yields no solution at all. You cannot get an answer because the closure is simply invalid. So, I mean, of course, that in general require a bit of CG expertise. I think the other thing I would like to say, okay, the previous question asked how you run bit uncertainty. So we actually we have games version of CG model. We make it quite small, And we run like kind of stochastic simulation for climate validated, so climate temperature change across different world region. We run like 100, 500 simulation, and we get a lot. So using the CEBRAnar model is quite fascinating. So I think you're right, Matthew. You have to reduce model size to be able to run this large number of simulations.
Yeah, that's one we should connect on, actually.
Yeah.
I think that would be really good for us to do that. And it sort of harks back to Andrew's questions as well, and how we might implement them.
Yep.
And the targets package was originally written into this package, and I pulled it out at the last minute because it was no longer, the costs were more than the benefits. But what you can do now is you can place this package in a targets pipeline, and you can define a vector, any vector you want, and dynamically branch over that vector with the CG model itself. So yes, you can run as much CPU as you have. You can run as many simulations. Yeah.
Thank you.
Thank you.
Okay, great. So we are at time, so we might wrap up there. But thank you so much, Matthew and Tom. It was really informative. Really enjoyed that. So everyone, keep an eye out for our next webinar, which will be held in December. But thank you everyone for joining us today, and it was a really interesting presentation. Thank you.
Thanks.